Some irrigation systems have moisture sensors and also rain sensors. Just to let you know what the evapotranspiration or sometimes they say ET, it's basically that every state or city have a certain amount of rainfall that they have every year. And they base that evapotranspiration on that. So it in different areas of the states, some people get a lot of rainfall, some people don't. So you have to adjust your irrigation based on the climatic data that you get from the amount of rainfall you get every year. But some irrigation systems have moisture sensors and some of them have rain sensors. The difference between the two, the moisture sensor is a sensor that goes in the soil and it measures the water content to determine if the soil needs to be irrigated. Some irrigation systems controllers have got a little bit more efficient where they can put a moisture sensor on each particular zone in those areas. So if those areas water content is high, it will abort the program for that particular zone that day. A rain sensor is just a rain switch where it's measured by rainfall. So if it rains at least 1 inch of rain, it will actually turn the system off for that day. But it's not as accurate as a moisture sensor because if it rains we have a fast shower for like 15 minutes, it may have rained 1 inch of rain, but if it's real windy or it's real hot, the rain sensor material will expand and release the switch on the irrigation system. And also another aspect is that the irrigation controller programming data. So a lot of controllers, some controllers right now are Wi-Fi controllers. So if we have a power outage, your data is not lost because it's on the cloud, and then the controller will communicate with the cloud to maintain that data. On a conventional controller, it's used as a backup battery, like a little 9-volt battery that retains the data. Only problem about that one is that if you have a long power outage, that the battery goes down and you lose all the data. And some areas, some cities and municipalities where areas are less than 10 feet to 4 feet, they are requesting that irrigators or landscape architects make those areas using drip irrigation instead of using spray heads, because those areas are real tight, and we have a limited nozzle use where some nozzles will spray 10 feet, but if the pressure is high, it can spray at least as much as 12 feet. So in smaller areas between 10 to 4 feet width in a strip of grass or a strip of bed, they requested to use drip irrigation to save on water. Because once the water hits the concrete or street, it's considered lost water. And in some areas where irrigation meter is a good option to have, because most cities, if you tap into your domestic water supply to install an irrigation system, you're going to get charged a sewer charge, and it's based on the amount of water you use. So usually, let's say you use $200 worth of water, you're going to get double charge for the sewer charge around about the same price. So when you install an irrigation meter, you only get charged for the water that you use. So sometimes a sub meter or irrigation meter is the best factor if you're doing a project that's going to require a lot of water, where you can save the owner money in the long run. So that's on irrigation.
Okay. So this is continuing with what Harold said. This is part of the ordinance. They changed the requirement to have dedicated landscape water meters for over 5,000 square feet. So now if you're working on a project where the site is larger, like a half acre or acre site, then if it's more than 5,000 square feet, you need to have dedicated landscape water meters. And also for each of the zones, you have to have pressure regulators. All the components have to meet the ANSI standards. And even though it seems understood, but some cities, they ask for the specs and they ask to show that it meets those standards. You have to have flow sensors for landscapes that are greater than 5,000 square feet, and also master shutoff valves. One of the projects that we were working on, this was the comment from the town of Atherton, where we didn't have a master shutoff valve. And the minimum width of areas that can be irrigated by overhead irrigation has been increased from 8 to 10 feet. It also applies to turf blocks where the paving includes turf in it. So you have to have, if it's less than 8 feet, then you can't have spray irrigation. You have to use drip irrigation. The irrigation auditor has, always should be a third-party person and certified by US EPA. So there's some common misconceptions I just want to go over. The first one is that lawn is, when you use lawn anytime, it's considered high water use. But some cities allow it to be included as a moderate water use if you use drought-tolerant grasses. And there are several drought-tolerant species that you can use. You can combine the zones with other moderate water use plants. So the diagonal hatched is lawn. But when it comes to irrigation, you have to separate the zones, because even though they're both the same water usage, the timing for the lawn would be different. So you have to put the lawn on a separate zone and the adjoining planting on a separate zone. If you use moderate water use plants, like in this case, I used a lot of fern as ground cover, which is considered moderate to high water use. But if they're used in full shade, they can be considered low water use. So these are some of the things that can have you include some plants that would be considered high water use, but if you use them in full shade, they can still meet the maximum allowance. So this is a recent project that Harold and I worked on. And on this one, the detention pond was recirculating water, and it was stored in tanks. And what we learned was if the recycled water is used to water drought-tolerant plants, then it's considered low water use. But it just depends on what type of plants are being watered. And also, they asked for a master shutoff valve for this job. And the lawn has to be minimized. So this job had several high water usage zones. They had fruit trees, they had a vineyard, and they had lawn. So each of them had to be minimized as much as possible, including the lawn. And the only area that got sprinklers is the lawn portion, which had to be minimized quite a bit. This was a very steep site, and one of the things was that whenever I start on an irrigation design, I try to minimize the amount of components, the amount of drip irrigation. In this case, the spacing could be increased. So instead of 18 inches on center, the drip lines, because it was such a steep site, was 3 feet on center. And that kind of reduced the amount of components, the amount of plastic that was used. Also, pressure regulators have to be used for steep sites. And the slope of the land defines how many zones there are. So if the slope changes quite a bit, you have to change them and put them on separate zones. This was a green roof we worked on last year, where the green roof had very porous soil. So the soil required the drip lines to be very dense. So they were 4 inches apart, and the water usage is very high. So regardless of whether it was a sprinkler system or a drip irrigation system, the water usage was the same. So in this case, only the grasses receive sprinklers, and one of the comments we received from the audit was that there should be no overhead spray to the adjacent roof, and if it is there, then it should be gravel. So there needs to be like a gravel buffer between the edge of the soil and the planting. San Bruno's more recent project, where one of the comments the city had was that because there were so many utilities, you have to make sure that the utilities are clear from the irrigation system. So always remember to coordinate your plans with the other sub-consultants like the civil engineer, because sometimes at the last minute, everything gets submitted and you may not have the opportunity to make sure that it's all separated. And this was a steep site in some portions, but because overall the slopes were the same, I continued the irrigation as one zone. As long as you're within 300 feet of the drip line, you're okay to do that. In 2017, we worked on Great America Parks, their irrigation for the new ride. And this was very challenging because they have all the water is reused from a lake, and it's brackish water. So all the components had to be brass components, which were specified by the facilities team at the company. And they were pressure regulators because it was very high pressure, and there was a green roof, but the green roof was on a completely separate system as the rest of the project. So now, Harold, we'll talk about the irrigation systems he's designed.
Yeah, this right here is a small project. It's like a townhome kind of. They had a swimming pool in the back, and the owner had pots that she wanted irrigated. So we put some emitters in the existing pots, and we put that on a separate zone because the water requirements was different from any other area. It's full sun, so it required a little bit more water than normal. And on the where you see the dotted lines kind of running vertical and horizontal, those are drip lines for existing flower bed, a landscape bed that we put on a separate zone also. And in the area where you see the half circles, the full circles, and the quarter circles, those are actually spray heads, and we use MP rotors, which is a water-wise type of nozzle where it conserves water, but it also saturates the area in a short amount of time. So we use that for this particular project. We'll go to the next. Yeah. This right here was a motel that we did, and we had to, our water gallons per minute was kind of low. So we had to do this in a 10-zone system to accommodate the amount of water usage that we had to use. And the circles part, the full circles and the quarter circle, that is the turf area in the front that we use to irrigate it. So we had to do at least 2 zones just to accommodate that application. And along the parking lot where we had turf, and we also had a landscape bed going along the parameter there. So that was on a separate zone. Where you see the little lines where it has numbers, that's the size of the zone, which is a 1-inch irrigation valve, and the gallons per minute. And along the back area, the owner had a garden, so we did a garden area in the back. And the next one.
So the back is where the drip lines are?
Right behind the building is a garden area.
Oh, okay, good.
Very back along the back part, all the way to your far left on the other side of the road, that's a drip area too.
Okay, good.
But that's a gravel and plant area. We had emitters and also drip line. So a tank is in the ground with reclaimed water, and there's a booster pump that's tied to the tank. We use the reclaimed water to irrigate the whole site. So the owner didn't want any drip irrigation on this site due to the fact it was an animal shelter and the dogs may get into and damage the drip lines. But the restriction for this town where you see along the road of Inwood Road, you see spray heads along there. So those are center strips along there, and they didn't require you to have drip lines in those small areas. But on the other side of the walkway, that's turf area. We see the half circles and the quarter circles. That's all turf area. And the area in the parking lot is still spray heads, and we got side strips and center strips. And those little dotted lines that's going across the parking lot, those are actually irrigation sleeves. So sometimes when we have a parking lot, we have to recommend putting a sleeve in to run the irrigation under the parking lot, under the pavement. Okay. So turned out to be a pretty nice project.
So when you design a system, do you try to make it, do you try to minimize the use of sprinkler heads as much as possible? Or is it just, if it's a wider area, is it based on the area of the?
Yeah, it's actually based on the application, what you're using it for. Now, let's say if you had a small turf area, you'll probably use spray heads. If you had a large turf area, you'll probably use a spray head called rotor heads, which they are a larger head that shoots spray around about 25 feet and up. It can go up to 50 feet. So we use rotor heads for large turf areas. And we use drip lines for, especially for beds that are just long and linear type of beds. We use a drip line for that. If the owner doesn't like it, we strongly recommend it for us. Okay. Save a lot on water usage too.
And even if it's turf, like along this sidewalk right next to it, that must be turf, right? That's
turf area. And the area where you see the spray head is actually a landscape bed area.
Okay.
Yeah. This right here is another project where we had turf along the back of the building near the pool area. And we use a triangulated pattern to get the best coverage we possibly get. It is a shaded area because the sun, the back part was in the shade. If you see the kind of grid pattern that's going around the pool area, that's all drip irrigation. And along the perimeter of the property, that's all drip irrigation. So that was a long linear bed that had like one row of shrubs and trees mixed. So the drip application was the best method and probably the most cost-effective way to irrigate it, and low cost to irrigate that length of area. And along the front, along the side, on the right-hand side, that's also drip irrigation. That was a long bed full of shrubs too. In the front area, we had a mixture, kind of like where the canopy is next to the building. We had a mixture of turf and landscape. So we did a mixture in that area to accommodate the different types of plants. And they were real high water use plants. So that's why we lean toward more sprays in that area.
You mean right next to the building, right?
The owner wanted a lot of annual tropical, so they really wanted the landscape to look lush. So we had to use high water use plants for that area. So that's why we used a spray system, irrigation heads in that area.
So if you're forced to use sprinkler system because of the high water usage plants, what is another way to conserve water? Like, is it through scheduling, or like what are some of the ways, even with sprinkler system, to conserve water?
Well, what you try to do is try to use drip when can. Like, say, like this whole property is, it's like a rectangular, but there are shrubs going around this whole entire property. So I conserve water by using drip in those areas that with just a long linear bed. But everything is pretty much all the other zones around the property is drip. But a few turf area where we had to have sprays. But the way the owner wanted the curb appeal to be in the front, it was difficult plants that will accommodate the drip and also the maintenance. The people that maintain this property, they probably would have, damaged the drip with the high maintenance that this landscape bed required for the front, with the high water use of plants and the type of plants.
Oh, okay.
These right here are cut sheets and submittals that we normally send to landscape architects or architects. These are irrigation valves, and they are flow control valves. The handle you see at the top of the valve is a flow control valve. These are kind of valves you want to use if you can use it on every project, residential or commercial, it would be great. But if you can't, try to use these on commercial projects. Due to the fact that if you had a 10-zone system and you had one of the valves that were malfunctioning, sometimes if you don't have this flow control valve, you have to turn off the whole entire system. But you can isolate a irrigation zone that's malfunctioning by turning that handle on the top. It would turn off the zone, and you want to turn off the whole entire system. So we always try to recommend a flow control valve on all commercial projects. These right here are irrigation heads. These are rotor heads. The ones I was talking about using for large areas. So we use these for large turf areas, and they can spray from 20 to 80 feet. These are very good sprinkler heads. I mean, the Ultra is probably the one that shoots almost 50 feet. And the middle section area, those are called bubblers and emitters. I know we just talked about a project previously about emitters and the pots and stuff. So these emitters usually goes in pots, and the little round circle one like a little dart at the bottom. Those are emitters too. So the ones that have a circle around, those are called spike emitters. And the ones that look like a little dart, those are called just regular emitters. So you can put these in pots and also at the root zone of plants. You can just have a supply line, and you can put these emitters at the root zone of the plants.
So they're like drip irrigation, right?
Yeah, drip irrigation. Well, bubblers/drip. Well, more bubblers and more bubblers are emitters.
Oh, okay.
Okay, the next sheet, if there's a next sheet. Oh, yeah.
Yeah.
So this right here is a typical irrigation controller. This is a commercial version of one, and some of these controllers have modules. So you can buy a controller that only have 6 zones, but this controller can be expanded up to 42 zones if need be. So sometimes you want to recommend that for a commercial project, or you got projects that are going to be phased in. So you want to have a controller that you can expand and to add more irrigation without having to change out the controller. The object that's to the left is it's called a RPZ, which is a reduced principal backflow device. This device is used on a lot of California projects because it detects chemicals that are or contaminants that are in the water supply. If it does detect that, it will spew out the chemical at the bottom, and it protects the water supply. So this is one of the probably the most backflow device you would use at a school or especially at a restaurant. Anything where contaminants may be induced into the water supply. So this is probably about the one of the high use backflow device.
So is there a difference between what you use for commercial and residential, or this can be used for both?
It actually depends on what the architect recommends, but in my experience, usually on schools, restaurants, anything that's dealing with the food industry or chemical plants, this backflow device is highly used. And one thing about this backflow device, when you do projects with it, it has a pressure loss of 4 gallons a minute. So you have to be very conservative and keep an eye on your gallons per minute when you're actually doing the design, because you lose 4 pounds pressure and gallons per minute when using this backflow device.
Okay, so now we're at the end of the presentation. Does anybody have any questions of Harold or me?